Ready. Let's see the mic. Boom. Yo, good. Are we live, Mr. Eugene? Yes, we are. Very good. Please welcome to our next PyMunich meetup. I will try to be short because I also ask the speakers to be short, so it will be fair if I don't take like long with the introductions. So you probably know this meetup already. So the Python user group, basically now in Munich. I'm Anton. I'm really happy to welcome you here. It's an honor to have so many motivated people coming after work to see the talks, which will be short, but still. This was actually feedback of one of the previous meetups that we are more here to network and so on, and less for the content-heavy talks, maybe. Some of us, majority of us. That's why we're experimenting with new lightning talks format that we'll have today, and hopefully you like it, then we will keep it. If not, talk to me. We really adjust on the fly. Whatever the audience wants, we try to deliver. Now, we also have people online watching. Hi, I hope you can hear me. And I was pretty bold saying that we had hiccups for like 3 times, I think, with stream broken, stream accidentally deleted on YouTube, new created, link posted. It's annoying, we know, and we're sorry. So now me and Eugene, we had an agreement that if something goes wrong this time, and I'm not kidding, we shave our damn hair. That's absolutely serious. So no, also if you can also just make it kaput for fun if you want to see one of us bald. But good. Now, without further ado, I have to say first a big thanks to Vemolo, our host, because yeah, it's very cool location, and I think seeing this nice fancy venues every time is a lot of fun. It's also an interesting company, and I'm sure of interesting things to say. Okay, so please warm welcome and applause.
Thanks a lot. Thanks a lot. I hope I wasn't involved in that equation with that hair shaving thing.
Yours is actually nice.
Yeah, so I don't know. Maybe we turn off the light and then we just randomly pick people to shave their heads. Yeah, thanks a lot for joining this evening. Python was, by random fact, also my first programming language, probably for many people that are coming from a computer vision and that side. It's probably the weapon of choice. And based on that, it was also, probably you've guessed, I'm one of the co-founders at Vemolo, and also the natural choice to choose Python for our backend language. So in many areas, we use Python. Either for computer vision and AI, but also for classical for cloud infrastructure topics or backend topics. So therefore, we also have, of course, a slight interest that you get in touch with us when you are interested in anything. But let's jump into what Vemolo is actually doing. And you can see
I'll do it.
You do what? You press the button?
Yeah, now it works.
Okay.
The slides are there.
All right, as long as nobody needs to get their head shaved. Right, so we focus on parking and with a special interest in seamless parking. And we have different versions. We have currently these, namely 3 different products. We talk about supervision, car pay, booking. What we do is we install cameras at the entrances of different kinds of parking lots, track the license plate, and provide different services. Next to that, we not only install cameras, but we also install different kinds of hardware, such as the payment terminal that you can see there in the middle picture, but also exit screens. The exit screens are, for example, needed to give users a feedback that they already paid. So you drive in, drive out, get a feedback, hey, you have paid already or you haven't. And there's a lot of upside to this. It's on the one hand a better user experience, so you don't need to pay with cash, go to the machine anymore, but also environment, so you don't need to have like these tickets anymore that you just choose once. So you can do everything digitally. But if you have more interest in that, then please approach me. And the last part is also we have in urban areas many free parking lots. meaning, for example, you can imagine a grocery store such as Edeka, Lidl, and so on. They have empty spots at night, and these are not utilized. And before, there was no option to really utilize these parking in the future, or with platform, we will enable to connect like these free parking lots to our platform, so people can use them when, for example, Edeka or other supermarkets are closed. We're currently building up more and more, or adding more and more parking lots. And I think in the future, this will be like a very nice thing, or like impactful vision to make our cities more utilized. So here's a brief overview how our system works. So as I mentioned, you drive, and then the camera detects. So on the technical side, things that happen. So we have an AI algorithm that we built in-house, and then it runs on the edge on the device, and then we detect the license plate and only store the image locally, because we need to be GDPR compliant here. And images are only sent to the cloud if needed, when somebody, for example, didn't pay for the stay. And then the person, for example, parks. Now you have different options to pay. You can either go to the parking terminal, or you pay, or you scan the QR code, pay with your smartphone, or maybe you are in the future a user and have already your payment method address, and the whole parking process will be automatic. So you drive in, drive out, and then you just get a push notification that you paid. There are situations such as people that go to a gym on a weekly basis, or go to somewhere else, like to a tennis court or so on, where they don't want to do this every time. Also, we have other situations such as maybe hospitals or people with different kinds of employees that maybe come just once a week to work, and then they just want to get like a monthly invoice for all the parking events that they had. Yeah, and lastly, as I said, then you drive out, and currently our system offers the option that you pay 24 hours afterwards. So you could theoretically just drive out and then back at home just pay by typing in your license plate. Yeah, as I mentioned, the majority of things that we need for the system are built in-house. So, for example, detection algorithm, the cameras are designed together with a partner. Even the payment terminal is something we built from scratch. If you're interested, we have back in the office, we have like 3 of these payment machines. The software on the payment machines is also very designed from our side, with the vision that down the road people can get the same experience on the device, also on the smartphone. Yeah, so here is us. So we are currently 230 people. We are active in 6 countries. So the German-speaking countries, Poland, Denmark, and Italy. Also, of course, looking for even more countries to expand to. To put it into perspective, we currently have like 1,800 parking lots. We have like 5,000 to 6,000 AI cameras. Quite a lot, and we talk about 1.5 million cars that on our parking lots on a daily basis. And I think one thing is people usually imagine cameras and then the thing will work. But based on my experience, when I was installing cameras and running the first 10 systems, I knew it's one thing to have it on one parking lot and another thing to have it on 1,800 parking lots. So the scale, everything that can go wrong, just potentially gets really, really, really more complex. But I'm no longer an expert in this, so we have like a couple of engineers here in the to reach out to the engineers later on and ask them the more detailed questions. As I said, we have multiple positions that we currently look for. One thing is software backend engineers, of course, with a Python skill set, but also related is also IoT engineers that are more focusing or leaning towards the hardware side of things. I think with that, my part comes to an end, and I am very, very happy to hand over to the next speaker. Thank you.
Let's have applause for Bastian, was it?
Yes, yes, yes.
Thanks to Bastian. Okay. Zvonimir, please take my place now. This is going away. So our first speaker from Vemolo. Yeah, I hope you will not report child labor to Jugendamt, but he's co-organizer actually, Leon. So Zvonimir will tell us about No-GIL. And if you don't hate GIL yet, please do hate it because it's bad. And Zvonimir will tell us why exactly. So please.
Maybe I won't.
Warm applause.
Okay. Hello. Oh, it's sharing already. Great. So I'm Zvonimir. I'm a software developer, actually Python developer here in Vemolo, and I want to talk about a new feature in Python. So Python 3.13 was released last week, and there's one cool thing in it. It's PEP 703, making the global interpreter lock in Python. So we actually are seeing GIL going away. This is a really big topic, and there's a lot that said about it, and I have like 5 minutes to try to summarize it. So I'll just get started. So basically, how does GIL work and how does Python work in general? If you have some Python code, it gets compiled first into a bytecode, which is something, as you can see there, maybe it's too small, but there's a set of simple instructions which are executed one after another, and they're basically not thread safe. So for this to work correctly, what Python does, it has this global interpreter lock, which is used as shown here. So one thread acquires the lock, then executes a number of instructions, then releases the lock, and then another thread has the option to run it. The consequence of that is that if you have multiple CPU cores, you basically don't get any advances from it because only one thread runs at a single time. There are some exceptions to that, but we'll come to that later. But basically, it's a problem, and the question is, why is it like that? Actually, this is faster if you have only a single thread. It is also faster than anything else if you have only a single CPU core. And when this was implemented, all the PCs had only a single CPU core. Multiple CPU cores came like 15 years after this was implemented. And they came out 2005. And ever since then, people have been thinking about removing the GIL. And they haven't until now. The question is why. It's actually quite simple to remove the GIL. You remove the GIL, and then you have to implement something else to protect things which need protection from concurrency issues. So objects which are accessed by multiple threads need to have some mutexes, and people implemented that. It turned out it was terribly, terribly slow. It didn't work well. And not only it was slow, it actually, if you added more threads, it didn't get faster, but having more threads. And the main culprit there was the reference counting. So each object in Python has a reference count. It's a number which says it's referenced. And basically, almost anything you do, it changes often a reference count of one variable or another. And if you're going to lock a mutex for each thing, it's going to be too slow. So that failed many times. And then this guy from Meta called Sam Gross, he just did it a couple of years ago. He spent some time doing that thing and then optimizing everything that was slow. He did many changes on the reference counting, like fast reference counting, deferred reference counting, immortal objects, all sorts of things, and other optimizations to actually make it work. And now we have it. And I ran some benchmarks to see how it actually works. So what I did is I compiled Python 3.12, the latest version, and 3.13, and the 3.13 version without GIL. So the option without GIL is not the default. You have to choose it to compile with it. This is all release candidate 2, which is not the latest version because I did it like a couple of weeks ago, but it should be similar. And I had 2 tests here. One is a very simple loop which loops for millions of times and just increments one integer to see how it works. And another is a recursive function. So for this loop, you can see the first column shows one thread option, where 312 is the fastest, 313 is a little bit slower. If you remove GIL, it gets a little more slower. But then if you add more threads, actually the version without GIL gets faster and faster and faster the more threads you have, because it's usually using multiple CPU cores at the same time. With the recursive function, it's a little bit worse. So this is like 50% slower than with the GIL. But then again, if you add more threads, it gets faster. This is the same thing with a different view. Previously, it was time per unit of work. This is work per unit of time. And you can see it most linearly going faster and faster, doing more and more. And it stops around 12 because I ran this on a CPU with 12 cores. And after that, it doesn't get faster. There is a special case I just wanted to show, which shows that GILs is not that bad, as Anton said. So many operations will actually release the GIL anyway. So if you're running something in NumPy, it will release the GIL. The way NumPy behaves in multiple threads, I don't know, maybe I had a weird test, but basically it's the same with the version with GIL and the version without GIL. It also doesn't matter, because while the system is waiting for some file system operation or user input or network or whatever, it will actually release GIL. GIL doesn't cause any problems. So where does it end now? So you have Python 3.13. You can build it with GIL or without GIL. If you're on macOS or Windows, you can choose to install the version without GIL. Should you do it? You can try it. Basically, it should work, as I showed here. It will be slower on single-threaded options, but one thing is many C extensions, many libraries maybe won't work well. So they have for years been expecting GIL to be there, and maybe they don't have thread safety implemented correctly, and they may fail. But if you are a contributor to some library, you should definitely install the version without GIL and try to fix your bugs so that soon enough we can have a Python without GIL working everywhere. That's basically all for me.
Big applause, big thanks. Questions? We have just one question slot, so you'll be lucky if that's you. Any questions? Okay, yeah. Please just say it and I will repeat it, because we have just one mic. Yeah, you had a question.
Yeah, well, what about sometimes you have synchronization issues where you need to have exclusivity. So what means can you offer instead of GIL? Is there some semaphores that should be used like that?
So repeat the question, please.
The question is what happens if you need to have multiple threads and you have how do you frame it? You need to have some protection. So basically, what they did, they didn't just remove GIL. They added mutexes wherever they were needed. In some cases, they tried avoiding them. In some cases, they implemented really fast mutexes. So for collections, lists, dictionaries, they have really fast mutexes. And for reference counting, they're not. They changed the way it works, so you don't have to decrement and increment the reference count always. So for example, for immortal objects like integers from 1 to 100, they were also reference counted always, although they always exist, but they now remove the reference counts from those objects. But mutexes are there, and it all is working as you would expect. So they didn't just remove GIL and make it not thread safe.
All right, then big thanks again. And let's wait for our next speaker. So our agenda is 4 talks. Since they are short, we are not making breaks. There is proper food coming. So yeah, we're not like forced soon, because talks are short anyway. It doesn't make sense to spend a long time. And also on the Q&A, that's why one question rule, because we will have a networking session afterwards, which is kind of the whole idea of this event. So keep your questions to the after party, so to say, when we have food, drinks, and we chat about everything. And now let's give a warm welcome to Jeff. Thank you.
Hello. So first of all, good evening, everyone. Today, my talk will be a little bit more hands-on focused. So compared to other speakers, they can provide you a thought leadership. My one will be more practical, but trust me, I think you will learn something from today's talk. The session is about building AI SaaS on cloud. It's more hands-on guide. And my name's Jeff. I'm a senior solution engineer at a cloud provider called DigitalOcean from United States. I currently live in Munich for around 7 years. Originally, I came from Taiwan. I think right now I get used to all this European style, so I will never come back to Asia. Just for kidding. But since I only got 10 minutes, I will squeeze a little bit faster. Today, I will show you a demo about how I build an AI SaaS in 10 to 15 hours. And I will tell you what I see from the market. So first of all, I want to ask, it's already around 3 years about this AI boom. How many of you want to build your own AI SaaS venture? Please raise your hands. Perfect. I also want to raise my hand, and I got so many ideas I want to implement, but why I only create one? There are a lot of things that hold you back. For example, you are not sure how much money you need to invest in. This is the first uncertainties. The second one, with the AI, either you want to train a model or you want to inference. You need to have a GPU. Otherwise, you need to wait for a very long time. But these two resources were a little bit more fall short. But today, I want to focus a little bit more about SaaS expertise. I compile 5 elements that you need to have to build your first SaaS MVP. The first one is about system design. I will use a standard 3-tiers web application as examples later. And the second element is user management. You need to ensure your users can register and log in. And obviously, forget the password. We all know that. The third one, payment. Payment is really important. It does not just mean that you get money, but also to predict your monthly recurring revenue. So you know whether your ideas do get people to pay to use. People who are willing to pay for your applications, they are your true customer. The fourth and the fifth one, scalability and monitoring, I will talk about that later. But I want to starting from this part. So I'm going to provide a quick demo. This application is called StoryForge. It is a children illustration book creators powered by Stable Diffusion. Have you guys heard about Stable Diffusion before? Perfect. Then I don't need to do a demo again. So let's focus on the architecture within these yellow rectangles. So it is a standard 3-tiers architectures. Front end, I use Next.js. The back end, since I need to host my model and use Stable Diffusion framework, I use our new product, GPU Droplet. Bear with me. Sometimes I will use my company's resource because it is free. So I will chime in with some company's product names. And the data layer, I use MongoDB. So let's have a look. What is that? So StoryForge, you can easily visit from the website, which is called storyforge.isfusion.cloud. Let me log out first. And full screen. Yeah. So this is a landing page. So click the begin. And then we will redirect you to the authentication part. Either you will register for a new account or you already have an account. So let's assume we all have an account and log in. Once we log in, we will have the user ID. User ID will fetch the relevant data from the MongoDB. So that on the left-hand side, this is the menu bar. You can see those items. Those are some relevant data associated with these users. And from here, you can also see there are 78 tokens available. So I designed that every time you generate a pictures, it will consume 1 token. And in the main canvas, you can see how you want to create the image. So let's use the example from on the line. So because I'm really lazy, so I designed tap to paste. So I click here. So I will put the name of the pictures on the top and also the descriptions. The description is called prompt or let's say text to image. So the way you want to portray your image. So let's click generate. Once it's been clicked, a prompt was sent over to the backend, and the backend will start to inference from the existing models. So this is a result from list descriptions. And you can also easily to zoom in to see a higher resolutions pictures. You can download it, no problems. So we can also create another one. Let me see the time. I only got 4 minutes left. So maybe starting from here. PyMunich. A group of Python engineer drinks beer and eats pizza. Let's say PyMunich. So let's see what result we got. All right. I think it fetched the gender diversity. So we got a female, we also got a male, and everyone really eat pizza. So that's all about this quick demo. So let me switch back to the slide. So just want to recap what we see today about these architectures. So 3 tiers standard web application architectures together with the Auth0 for authentication and authorization, and also Stripe for payments. So when you click the tokens, you can easily go to the top up, and then you can start to get more, let's say, people who want to pay for your applications. So what happened under the hood is that I use some of our company's products that already integrate with the CI/CD and the monitoring, and also with the Auth0 single sign-on will be fully covered. And the payment from the Stripe can ensure you got the money from your subscribed users. High availability and also database management can also be leveraged by the relevant products. So this is like the trend that for most of the startup, they want to capture the time to the market, be faster. So they will leverage the power of the platform just to validate their ideas. So once they got validated, they want to scale to the production. There are some couple of areas they can focus on. On the left, you can start think about how to scale automatically. The second one, how you get more granularity and transparency on your systems. The last one, how to ensure security. For example, VPC peering inside your application, so your data is not visible from the public internet. So it's almost come to the end, and I want to also point out that maybe some of the audience, you don't know, you want to learn, you want to build your SaaS, but you are not sure about how much code you need to do. So just to keep you have more motivations, you can starting from Hugging Face. They already have some web interface. You can just put a text and it will generate image. Depends on the model you choose. The second one about the tutorial is that I wrote a tutorial on my company. It's called Stable Diffusion, made easy. You can just easily copy and paste. That's it. And then you will have your own Stable Diffusion GUI running on the public internet. So just a short commercial. We are going to have a new product called Gen AI platform. If you're interested, let me know. And thank you, everyone.
Big thanks to Jeff. Now question. Just one. And here you are. Yeah. And repeat the question, please.
Sure. So this gentleman asked, what is the Gen AI platform from my last couple of slides? So in my opinion, in the generative AI world, they are like art, like the pictures, and another one is a language, more about the text. The Gen AI platform is focused on large language model. So you can easily use all kinds of open source large language model on this platform. You can not only treat it as a large language model as a service, also include how you can validate like the accuracy of the result, and you can also do fine tuning on top of that. So this is what we call Gen AI platform. Last but not least, this Gen AI platform can also deliver this large language model as an API endpoint. So it's like the backend, just plug and play. Exactly, guardrails also include. For the observability, I need to check because it's right now it's a secret right now. All good.
All good.
Yeah, great.
Big thanks again to Jeff.
Thank you, Anton.
Okay, we are welcoming our next speaker, Oscar. Easy.
Yeah, hello.
Yeah, two more talks, so we are in the middle now. And I just saw that there is pizza arriving or arrives right now, but don't worry, our love to Python will keep it warm and ready for us. So please make some noise and warm welcome to Oscar. Yeah, it's there. All good.
Okay, thank you very much. And I just have a question. In German, we have a word Sicherheit, and in English, we have safety and security. Who knows the difference? Okay, well, maybe I just explain. So security is protecting us against other people who want to hack us or want to do mean to us or against people. And safety is protecting us against our stupidness in making errors. So that's, and today we are talking about the safety, the functional safety. So meaning programming errors, tooling errors, all those kind of things. And I just say one thing about, or some things about Validas, my company. We're about 70 people from over 20 different countries. So it's like a nice mixture. And we are specialized on the qualification of tools and libraries for functional safety, hopefully in the future also for security. Yeah, what we do have many big customers over the world, so BMW, NVIDIA, or others, and we have a certificate that our processes are good and we can guarantee success. But that's the vision, of course, is to make the world a safer place, and the vision is the mission is to contribute for the safety of tools and libraries. And how to make a system safe? Yeah, well, you need to have a safe system concept, and then you build it using hardware, using software, and using tools. And of course, every three pillars have to be safe. That's the foundation. And yeah, how to make a system safe? Yeah, how to achieve this? The first thing, you need to analyze the risk. What is dangerous and what not? Is Python dangerous or not? What do you think? Can be dangerous. Yeah, can be dangerous. Yeah, it depends on how you use it. That's exactly the analysis. First, we need to determine how dangerous is Python, and then we can try to reduce it by testing it, by qualifying it, or by using it carefully. So that's a typical thing, and this holds for the system, this holds for the software, and this holds for the tools. And Python I would consider mainly as a tool where we have some variants, and that's where we'll be looking at. Before we're looking at Python, I need to introduce you to the risk classes. So there are different risk classes. And, ISO 262 is a safety standard for automotive, and it defines tool confidence level, meaning how much confidence do I need into this tool. And yeah, the first step is this tool used in a dangerous way? So that has an impact. So can the car crash because of the tool problem? Yes or no? And that's, tools can insert bugs from, let's say, a compiler can compile a correct program to a wrong binary, and then the car crashes. So we have seen people going to hospital due to this compiler errors. But tools can also fail to detect. If the testing tool says everything is good, but isn't good, then it's also dangerous. So first question, has the tool an impact? And the second is, how likely is that we would detect the error? And that is something, if, let's say, the compiler does something, and I really do intensive testing afterwards, they might have a good probability or better probability. But if I don't test on the target, but only in a simulator, then I will have no chance to find the compiler bug. And that's one thing. And you see here in the table how the tool confidence level is computed. And tool confidence level 1 means this is a harmless tool. You can use it carefully, but you can use it. And tool confidence level 2 or 3 means a bit dangerous or more dangerous, and you have to qualify it and test it. And now the question comes, yeah, how dangerous is Python? So we can look to a typical Python script that is interpreted, and it depends on what the script does. So I cannot say in general everything you do with Python is okay, or everything with Python you do with Python is dangerous. So we need to look to every single script. So if I have a script that, let's say, configures my compiler and then compiles code, could be dangerous. If I have a script that just shows me some graphical visualizations of my data, or maybe, as we have seen previously, configures my SRS service, worst case, I lose a coin. Yeah, but maybe for him it's critical, but nobody will harm by this. Nobody will get hurt. So then might be an uncritical users of Python. Yeah, we have also MicroPython that compiles Python to binary like a compiler, and this can be more critical. But there is an impact, that's for sure. But what kind of errors could go wrong in MicroPython? What kind of tool detection do I have? Well, if the compiler crashes during compilation, I don't have a problem. Nobody gets hurt. So that is TD1 uncritical. If there's a syntax error in my Python program, that's not a tooling problem. It's also out of scope even. If the Python program loops endlessly, or the compilation loops endlessly, it's a runtime error, no problem. It gets more trickier if we have a correct program and than the wrong binary, as I told. And this, we need to qualify this. This is critical. So this is the first time you see TD3. And yeah, intensive testing, maybe we can test every binary statement that comes out. And if we have tested them all, we know it's correct, but nice. So that's not a good alternative. Yeah, and another very dangerous thing is implemented things. So if you know the XZ attack that has been backdoor, so this really, so if somebody has an open source compiler and someone else introduces a backdoor, well, how to ensure this? Yeah, we need to qualify the compiler and really test that it doesn't do anything it can do. And also there, and this is another category. So the tools are out of the car, not going to the car, but the libraries and the runtime libraries, they go into the car. They need to be qualified any case. So that is more critical. And of course, Python modules, if they are just part of the Python interpreter, then we need to classify and qualify them. If it's going to the library, then we have to qualify it. And most critical, and that's really the software that goes into the product, if we have something like embedded Python. So really Python running on the device. So that is then something which is like a software specifically developed and to go through the whole safety standard. So, and this is part 6 in ISO 262, which threatens many people, and people say it doubles or triples the effort to go through such a safety standard. Yeah, that's already the summary. Question was, does Python need to be qualified for safety? And the answer was, not surprisingly, it depends on, yeah, the use case is an interpreter, compiler, or embedded. It depends on the classification and the analysis. And we have to look to every single Python program. So I cannot say yes or no. We have to say to every single Python program. So I can go to all the talks and say critical from the safety point of view. Yeah, the compiler needs to be classified and qualified. If you have something embedded, then really is highly safety critical. Yeah, but on the other side, having not qualified things, just if we would have a qualified Python compiler, then we could build self-driving cars with it without getting into troubles. And so this is like a vision, a dream. Currently, I'm not aware of any qualified compiler for Python, but if we would have it, then we would be allowed to run all our programs in the safety-related things. Yeah, and that ends my talk.
Thank you so much. Question, please. Please repeat.
Yeah, the question was how do we classify programs? and whether this is a code review or whether these are formal things. And for the tool, I have shown you the tool confidence levels, and these are, let's say, very well defined, and you just need to say how dangerous it is. You always do it on the risk analysis. You cannot look into the code, then you see whether it's good or not. It's a black box activity. You just need to assume what would happen if this program had a bug or the software has a bug. So how dangerous? So if you have, let's say, a self-driving car, and if you look to the brake that brakes the car, what would happen if the brake didn't work? Well, you can brake and you would crash. It could be you could die. And this is the way how you classify it. Okay, I could die. This is very dangerous. If it's just let's say the radio in the car wouldn't work, it's not so dangerous. So you always look to the worst case. What would happen then? So that's the way how you classify software and tools. Always doing this kind of risk analysis. Yeah, in the break we can have more talks. I can tell you stories about tools that really break things and are very dangerous. Okay, thanks a lot.
Yeah, thanks. Please talk to Oscar also after the talks. I have a question myself, but rules are rules. I cannot ask it now. I'll have to wait till the end. Okay, our final speaker, Ludwig, please join us. There are, by the way, 20 people watching this online right now. So far, the complaint was that the audio is a bit chopped. So I'm not sure, should I chop my hair a bit, or it still qualifies as a good stream? Please write in comments, because yeah, I'm honest. Yeah, and I hope you like the audio setup, because we are streaming with this mic and talking with this. This is like the Python solution, I would say, Pythonic. Good. Ludwig, warm welcome, and let's have the final talk.
Okay. Thank you, Anton and the whole team for the introduction and having me on this talk today. We heard a lot of great talks already, and I'm here to round everything off with a bit of introduction how we C++ developers use Python to make dependency management quite a lot more easier and not a headache at all. Okay, quickly, I'm a new guy, so I want to quickly introduce myself. My name is Ludwig. I'm here from Munich. I'm 24 years old and actually not a programmer. I'm an electrical engineer. And I'm currently working at Maurer Rides, and I am responsible for building roller coasters, so nothing to do with programming at all, but I'm quite a big enthusiast on programming, which brings me here. C++ is like my soulmate, but Python is also a good friend, so yeah, I'm always happy to join the talks here. Okay, so let's get started about talking dependency management between C++ and Python. What's the difference? How can we do dependency management in Python, and how does it all work in C++? Okay, so I know we have quite a lot of other ways to do dependency management in Python than with pip install. However, I want to keep it a bit short. So how can we do it the most easy way? Like just pretending we have a completely fresh machine. We just want to do one project. How do we do it? Well, we install Python. We can run a single command. It gets all the dependencies that we need, resolves them quite nicely, all the versions, all good. Then we just write a script, use the library, and we run the script. That's it. We can do it like that. Of course, you shouldn't do it like that. You should be more involved if you're really a Python developer. But this is how it works. Now, how does it all work in C++? Well, actually, not that easy at all. In C++, we have a lot of things that we need to take care of to get our dependencies and projects building. And it's actually like 5 main steps. The first step is an environment. We do not just only have like Python or maybe like pip if you install it on Linux manually. We have like a compiler, we have a build system, we have different build tools that you might need for certain libraries in order to get the project running. So there's a lot of software that you need to take care of, that it's installed, that it's ready to use, that it's configured, and that you can start with it. The next thing is dependencies. If you're writing a project, you're probably not going to write all code on your own. You need libraries, some external code you pull in, that's open source, that's proven, that's already written and taken care of. You need to resolve them. The external code needs code. The dependency needs a dependency that needs a dependency. You need to get all of them on your machine. You need to make sure all the versions match up together so that they work nicely together. You need to make sure that they are compiled for your certain configuration you are targeting and that they are ready to be integrated in your project. Talking about the actual project then, you have a build system, compiler, and linker, and they kind of like work together so that it all has like a flow. Because in C++, every file is compiled individually. Every CPP file is compiled by the compiler and later on put together with the linker. And what you do is you put a build system on top that takes care of calling the linker. And well, good news, all these 5 steps will be probably different depending on which library you use. So if you are really, really unlucky, you have 3 different libraries that use a different configuration of this pipeline. And that's bad. You need to take care of all of that. And that is where Conan comes into play. Conan is a package manager for C++, and it is a Python project. It's like over 100,000 lines of Python code from nearly 400 contributors, including a bit of code from me. And it is also offering an online service with like 1,800 libraries that are ready to use. And how does it do that? Well, it works like a producer and consumer model. So basically, the library produces the build artifacts that are then back integrated into the Conan ecosystem, which is then used to produce the exact output you need for your build system, for your toolchain. And it does do all of that in the background. So how does it work? Well, we write Python code for it. And that's now where it's interesting for the meetup. It's quite simple, actually. You define your library, you write a bit of code, then you tell basically what you need. In this case, I've taken an example from a logging library. I basically say, okay, I need this formatting library called FMT, and everything else will be then handled by FMT. And I can just basically do everything that I need for my project. In this case, I'm basically telling SPDlog doesn't need examples if I use it as a library. I don't take care of that. Put it to false, generate it, and then if I build it, well, I then again just call CMake, because that's what SPDlog uses. And what you can kind of like see is a pattern here. So basically what you are doing is you're writing some Python code and you are basically scripting the build system. And this is all taken care of with Conan, and it then backfeeds into Conan again. And Conan then knows which dependencies and which code to deploy to your project, which you then can use in your project, where you just basically tell, I need SPDlog. And I can even go in and configure SPDlog to have it as a custom configuration, how I need it and how I like it. And you see, it is kind of like similar to a requirements file from Python, which you can just install. And that's what I want. I want to have simple dependency management. Okay, thank you for the attention.
That was perfect timing.
Okay, super.
Question. Just one, remember. 0. You're so hungry. Oh, okay. No, that was the first one. Please.
Yeah. Okay, so the question was a bit off topic. So it's more about the library that I've used here as an example. If I would recommend using SPDlog these days as my go-to logging library. For me, it really depends. In a logging library, it's more like what fits to your project. The nice thing of SPDlog is that it is using FMT in the background, and FMT is actually the, like, let's call it a blueprint that was used for the standard committee to actually bring in the default formatting into C++. And because it's using that, it is kind of like feeling naturally to use it these days. And it is also quite low on the dependencies. You can even modify SPDlog in a way that you don't need any even more dependencies. So you can just go with the standard library. And if you compare that to something like Boost, Boost is really like a big library. Of course, you can configure it to just pull in the things you need from Boost, but it's still big. So if you want to have something that's small, lightweight, and integrated in its own, I would recommend SPDlog, yes.
That was one question. Big thanks to Ludwig. One thing I want still to ask, like you were just briefly mentioning YouTube, your YouTube channel. Call it. What is it?
Okay, I have a YouTube channel that covers C++ topics. Currently, I'm doing a video series on, I call it commercial grade C++, which is kind of like a clickbait to get the people in the videos, but it's trying to like cover a bit how you would tackle software development in a professional experience. For me, it's more on the like engineering side, because I'm from an engineering company, and I use like my output is not primary to get an application running. It's more having an application that does something else. So if you're interested in that, you can visit my YouTube channel. It's called Ludwig Fusel, which is like a funny pun name that I was coming up during my studies, and it was never intended to be a channel that everybody watches, but people still came coming. And if you are interested in that story, you can talk to me afterwards why the name is like that.
Very good. Thank you very much.
Thank you as well.
On the next meetup, you should be subscribed, okay? And we also have YouTube channel like PyMunich, but you do not have to subscribe. Why? Because you should come personally. I want to see you. I love this crew. Good. So now it's time to say thanks. So thanks to Ludwig, to our speakers in general. We will do it again, but still a little applause for this Wonderful thing. Now this means pizza is there, so it kind of tells me to hurry up. Okay, we need more things. Eugene, can you come by? Okay, he's there. So our meetup is enthusiastic based, so to say. We are all doing it just for fun. We need speakers, we need hosts always. So if you don't like chips, maybe just take the sticker here, because on the back there is a directions where to write if you want to be a speaker. And with these talks dropping to 10 minutes, I think we will keep it. It's of course based on your feedback, but I think we will keep it. Like, it's really easy. Everybody has something to talk about for 10 minutes. So we are really enthusiastic to know what can you share with the community. Next meetup is in November. We still do not have a lineup, so very, very welcome to drop us a line about that. Also for hosts, although we have more hosts than speakers, we always appreciate this. This is like not a little thing. It's a big deal to actually provide the venue, provide the catering, provide the drinks. So we appreciate that a lot too. Yeah, then we have an agency. We have a Python software house. It's called Tech5. This is why we can afford a bit fancier setup with streaming and so on. So yeah, although this is a non-commercial event, absolutely, it's still nice that if you have if you're looking for freelancers, for some contractors, also drop us a line, because this is how the mechanics behind these meetups are spinning. Finally, I want all the speakers to join here, please, because at the end, this is the core of it. Like, nobody would come, regardless of location, regardless of snacks or drinks, if the talks would be boring. Do we still have Zvonimir? No, we don't. Yeah, we do. Okay, good. Do we still have Jeff? Yeah, we do. Okay, good. I think they deserve some applause. I will take a selfie. Okay. You too? Okay, good. Very nice. And Wemolo, someone from Wemolo, please come by. Probably you. Yeah. It would be also kind of cold if we would be on the street. So please, applause for Wemolo. That's it for the official part. Now, the plan is to network, because at the end, that is why we gather. It's not just about Python. We all know that. It's about meeting new people, making new connections. So shamelessly exchange your LinkedIn. It's okay here. Exchange your contact data. Ask speakers anything you want, because they are good. They can actually give some good tips. Talk to me about the meetup. You can say, Anton, it's time to shave your head because it was shit. And I will actually do that. So please, we are waiting for feedback, and we want some really good networking here, and let's enjoy the time remaining. Thank you.
If you have a question to me about tool qualification, which I cannot answer, then I will also shave my head.
Really good. Thank you. Thank you. Let's have some food. And we put some musica.